Hello, so this is a revision video for Edexcel A-Level Chemistry, Redox 1, 3.1, Oxidation Numbers and Rules. This is a revision video, so only the essentials are covered for revision purposes. For deeper explanations and for full video lessons, please check the links in the description below and visit chemistrystudent.com. Oxidation numbers help track electron transfer in reactions. It is straightforward to see how atoms have lost or gained electrons when ions get formed. However, it can be harder to see how atoms have lost or gained electron density when dealing with molecules. For example, when carbon gets oxidized to form carbon dioxide in combustion, no ions get formed, meaning it isn't immediately clear how electrons are involved. To help, we consider each atom as having an imaginary charge described as its oxidation number or state. There are various rules that you have to be aware of for assigning oxidation states. Uncombined elements always have an oxidation state of 0. We only have oxidation states other than 0 when we have elements in compounds. For example, in compounds, group 1 metals always form oxidation states of positive 1 and group 2 metals positive 2. Oxygen nearly always has a negative 2 oxidation state, except when it is bonded in peroxides. Then it has an oxidation state of negative 1. For example, in hydrogen peroxide, H2O2, oxygen has an oxidation number of -1. Hydrogen always has an oxidation number of positive 1, except when it's in a metal hydride, for example, lithium hydride. Then the metal has the positive oxidation state of positive 1, and hydrogen is left with a negative oxidation state of -1. In a neutral compound, the sum of oxidation states will be 0. In polyatomic ions, the sum of oxidation states will equal the charge of the ion. Using these rules, we can go back to our previous example and look at how carbon gets oxidized. The carbon has an oxidation state of 0 to start with because it's in elemental form, remember? But when it's bonded to oxygen in carbon dioxide in the product, it must have an oxidation state of positive 4. This is because oxygen will always have an oxidation state of -2 in a compound, unless it's in a peroxide, remember? Meaning if we have 2 oxygens with a -2 oxidation state, that's -4 overall, leaving a positive 4 oxidation state for the carbon, to make the carbon dioxide neutral overall. Well, we've gone from an oxidation state of 0 to positive 4, meaning an increase in oxidation number. It's got more positive. This means oxidation has occurred. This is actually covered in more detail in Module 3.2, Oxidation, Reduction and Electron Transfer. For elements that can form different oxidation states or numbers, like the transition metals, Roman numerals are used in the names of compounds to show which oxidation state or number the element is in. For example, FeCl2 is named iron 2 chloride because the Fe has an oxidation number of positive 2. FeCl3 is named as iron 3 chloride because the Fe has an oxidation number of positive 3.